All right. In this session, what we're going to talk about is deriving equations for a line. All right. So what we're going to focus on is what's referred to as the slope-intercept form. Slope-intercept form, in case you forgot, is y equals mx plus b. The reason it's called slope-intercept form is because from the equation we know the slope of the line and we know where the line crosses the y-intercept. So this is the form we're going to be basing all of our equations off of. And our objective in this lesson is, given information about a line, we want to be able to come up with the equation for the line. So this is key. In order to come up with the equation of a line, it's going to be important for us to know the slope of the line and also any point on that line. If we know those two pieces of information, then we can come up with the equation of the line. So, given that, there's going to be three possibilities, and we're going to go over them here on the examples. The best case scenario would be like example 1. Keeping in mind that we need to know the slope and a point on a line, example 1 automatically gives us the slope, and it gives us a special point on the line. The point we're given is actually the y-intercept. So if I needed to write an equation of this line, this is in slope-intercept form, y equals mx plus b. I will substitute the slope in for my m value, negative 2/3 x, and put the y-intercept in for my b. That's the best case scenario whenever the slope is already given and the point given is the y-intercept. Now, a similar problem is like number 2. We again are given the slope, right? But this time the point given is not the y-intercept. It's just a point on the line. So now, what we have to do now is we have to actually calculate the y-intercept, or necessarily our b value. So, if we reference our slope-intercept form, we can now take the y value from the point, substitute it in for y. Our slope is negative 1/2, and our x value is 8. By substituting those values into the equation, you see we now have an equation with just the variable b, which means if I solve this, this will now give me my y-intercept. So the negative 1 stays. Negative 1/2 times 8 is negative 4 plus b. Solving for b, I would add 4 to both sides. Negative 1 plus 4 is 3 equals b. As a result, I now know my y-intercept and I know my slope. So I can write my equation in slope-intercept form. Y equals negative 1/2 x plus 3. So in this case, we were given the slope and given a point on the line. And then we used the slope-intercept form to actually calculate the y-intercept. The third example will recommend the most work, because you see in this case, we're given just 2 points that are on the line. So remembering that we need to know the slope and a point on the line, our first step is to calculate the slope. The slope, remember, is the change in y over the change in x. So to determine the change in y, I take my y values, negative 7 and 5, and I find the difference between those two. To find the change in x, I then find the difference between my x values, 4 minus a negative 2. So this is going to give me negative 12 in my numerator. This gives me 4 plus 2, which would be 6, which reduces to negative 2. So keeping in mind, in order to come up with the equation of the line, I need to know the slope and the point. I can pick either of these points now, and they both would give me the same exact equation. So upon looking at it, they both have a negative, but these two are a little bit smaller, so I'm going to select this point now. Again, it wouldn't matter, all right? I could select either point, but now I just created this example to turn into an example like this. Here we had slope and a given point on the line. Now we know the slope and a given point on the line. So we'll repeat the procedure from the last example. We can write our slope-intercept form. I'm selecting this point, so 5 goes in for my y value. I calculated my slope to be -2. The x value is -2. And now I have my equation to calculate b. Solving this for b, I get 5 equals 4 plus b. Subtract 4 to both sides, 1 equals b. Therefore, my equation in slope-intercept form is -2x plus 1. Now, I said about a minute ago that we could pick either point. I'm going to go ahead and do the exact same problem, but this time I'm going to go ahead and select this point. Now, what will happen is you'll see by doing the math, I will still come up with the exact same equation. So now, let's go ahead and start with this point. Y equals mx plus b. The y value is now -7. Our slope is still -2. The x value is 4 plus b. This gives me -7 equals -8 plus b. Add 8 to both sides, 1 equals b. So again, you see that if we write in slope-intercept form, y equals our slope, -2x plus 1, we came up with the exact same equation. So again, that just solidifies that we found the equation of the line, and it doesn't matter which point we pick, we'll still come up with the same equation. So in conclusion, our objective was to be able to write an equation of a line given different characteristics, and in order to write that equation of a line, we have to make sure we know the slope and any given points to be able to write an equation in slope-intercept form.